All right, so here is our 7-3 assignment, and we're going to work through them 9 through 37 and 45 through 53 odds. I do already have the answer key from the PDF printed out, and so I'm going to kind of use this as a reference to the textbook instead of using the teeny tiny textbook. Okay, so the first thing that we are asked to do in our first problem, number 9, is to reference this matrix here, not these as those are the answers, and perform the indicated elementary row operation on the matrix. So what they want you to do is take R1, multiply by 3 halves, and then add it to R3. So let's go ahead and copy down our matrix. All right, and again, they want you to do the operation of 3 halves times row 1 and add that to row 3, which means that row 3 is the one that will ultimately change when we get to our answer. And so you can go ahead and fill in that it's going to be 2, negative 6, 4, 1, 2, negative 3, and then these will be the ones that change. So how do we get to that change? Well, we have to do 3 halves times row 1. And so 3 halves times row 1 is going to get us 3 halves times, so 3. 3 halves times negative 6 makes negative 9. And 4 times 3 halves makes 6. That is going to be added to row 3, which in this current state is negative 3, 1, and 2. And so if we add them as it's mentioning, we're going to get our new row 3, which is 0, negative 8, and 8. So 0, negative 8, and 8. How come they have 4? What piece did I miss? Oh, hi. There's a negative here. So therefore there's a negative here, which means it's not 8, it's 4. So one of my classic mistakes, copying the problem wrong. I wrote a 2 instead of negative 2. Super. Okay. All right. So then moving on to number 11. Again, this being your answer. Number 11 wants you to take the matrix that is still 2, negative 6, 4, 1, 2, negative 3, and negative 3, 1, negative 2. And you're supposed to do the operation of negative 2 times R2 and add that to R1. So because R1 is last, that means that R2 is going to stay the same and R3 is going to stay the same, but row 1 is going to be different. So that different row 1 comes from taking negative 2 times row 2, which is going to get negative 2 times row 2, negative 2, negative 4, and positive 6. And then we're going to add that to row 1, which is 2, negative 6, and 4. And so when we add them together, we get our new row 1, and that's going to be 0, negative 10, and 10. All right, and so this is our answer from that row operation. All righty. So then we move on to number 13, and then number 13, it says, what elementary row operations are applied in order to get from this thing to this thing? Super. So they want us to figure out what this piece is. So in number 13, we have 1, negative 2. Oh, sorry, the first one is negative 2, positive 1. -1, 2, 1 and 3, -2 and 1, 3 and -1 and 0, 2. And we're doing some sort of operation in order to get to 1, -2, 3, 0, -2, 1, -1, 2, and 3, 1, -1, 2. So if you take a look at the difference, this bottom row stays the same. This middle row changes, and this top row changes. And so remember that when you write this notation, this last piece is the only piece that technically changes. But going back to our notes, the other option could also be, and notice the difference here, that the first row actually becomes the second row. And so in that case, our row operation, again, the idea is that you switch row 1 and 2. And so how do we do that? We're going to do R1, 2. So that just means take row 1 and row 2 and switch them up. Again, that notation comes from the little box that was on our notes. This is right here, indicates interchanging the ith and the jth row of the matrix. Okay. So this is our answer for that piece. Then again, we're trying to identify in number 15 as well how they are getting from the original matrix here of -2, 1, -1, 2, 1, -2, 3, 0, and 3, 1, -1, 2, and how they get to -2, 1, 0, 1, -2, 7, -1, 3, -10, and 2, 0, 2. Sorry about this one not being on the line, so that's annoying. Okay. So on that note, row 1 has stayed the same, row 2 has stayed the same, and so we know that we're going to do something plus row 3. So for instance, we need to know, how do I get from 3 to 0? Well, it looks like I'm subtracting 3. Okay, from 1 to 7, I'm adding 6. From -1 to -9, -10, I'm getting a -9. And then from 2 to 2, I am adding nothing. And so very clearly you can see, especially on that last piece, that to get from 2 to 2, you're adding nothing. And so we can't necessarily say that we'd be adding row 1. So we've decided that we're going to do some sort of operation to row 2 and add it to row 3. So what do I do to row 2 in order to add it to 0 and get 3? Well, I'm assuming I'd multiply by 3. So 3 times this entire row makes a 3, a -6, a 9, and a 3 that I would be adding to the row below, which is this one. Oh, so I might actually make it -3. So it's -3 plus 6 minus 9 minus 3. Which is actually a 0 if you multiply. All right, so 3, positive, -0, and then we'd add that to the original row 3. And hopefully that gets us our new row 3, which is 0, 7, -10, and 2. So I guess kind of a little guessing game. But in that case, our operation is supposed to be -3 times row 2 plus row 3 in order to get from the original matrix they gave to this next one. All right. Then we're moving on to number 17, which has some new directions. So in number 17, again, ignoring the answer right here, we need to find a row echelon form for the matrix. So remember that row echelon form means that this all needs to be ones, and then under here needs to all be 0. So that one already is, yeah. So we need to make row echelon and not reduced, but row echelon form. All right, and so we have 1, 3, -1, 2, 1, and 4, and -3, 0, and 1. And so remember that the goal is to get these diagonals to be 1, which we already have, and then everything below it to be 0, which we already have for this one. So the things that you can do are switch around the rows, but it definitely doesn't seem like we would want to do that since our ones are already in the correct spot. So instead, what you end up doing is multiplying the top row, which already has a 1, by something that can then cancel with the rows below it. So, for instance, I'm going to multiply -2, because that's the opposite of 2, times row 1, and then I'm going to add that to row 2. So that indicates that I'm going to change row 2, so everything else will be the same. However, that middle row is going to, and now I have space to make my work here. So -2 to row 1 makes -2, -6, +2. And then to row 2, we're adding it, so that's just 2 and 1 and 4. And so now we'll add each of those, and that means we have new row 2 as 0, which is what we wanted, -5, and then 6. All right, and then to continue on our row echelon, we rewrite the one that we just got. So 1, 0, -3. And now we do the same thing as we did before. We're going to multiply something times R1 so that we can add it to R3 this time. And then hopefully we'll make that a 0. So what do you add to -3 to make it 0? A +3. So 3 times this whole row added to this whole row will make a 0 right there. So again, row 3 is the one that's changing, so we can rewrite row 1 and row 2 exactly how they are. But then our work is that we're doing -3, R1. So multiplying row 1 by 3, which is 3, 9, and -3. And then we're going to add that to row 3, which is -3, 0, and 1. Adding that makes a new row 3 of 0, 9, -2. All right, so now as you see, making zeros underneath a 1 did in fact change both of these to be not 1 anymore. So we have to go back and do that. So our new piece is to take the current matrix and make this second row, second column value into a 1. And so in order to do that, we're going to take I'm thinking only of dividing, so I guess we'll do that and get some really ugly fractions. So we are going to take the number -1/5 and multiply it by row 2. So if we do -1/5 times row 2, we're going to have row 1 staying the same, row 3 staying the same, but row 2 becomes 0, stays like that, a 1, which is what we wanted, and then sadly -5/6. -6/5. Either way, still sad. All right. Probably to save ourselves some stress, we'll just divide that and get 1.2. All right. So then to get our next step, again, the idea is to get that diagonal to be ones and everything else zeros. So we're almost there. And so in order to get our last number here to be a 0, we're going to have to multiply this row by something that will make an opposite of 9. So I'm going to multiply row 2 by negative 9, because that's the opposite. And then I'm going to add that to row 3, which is the one that's going to change. So that means that we need negative 9 row 2, and that's going to become negative 9 row 2, 0, negative 9, and negative 10.8. And then we'll add that to row 3, which was already 0, 9, and negative 2. And so now our new row 3 is 0, 0, negative 12.8. So our answer has become nothing happens to row 1, nothing happens to row 2, but row 3 finally has zeros where they need to be, and then negative 12.8. All right. Then the last piece is going to have to try to make this into a 1. And so how do we make a number into a 1? We divide it by itself. So our last operation is going to take our new matrix. So this is number 17 continued. And now our operation is going to be 1 over negative 12.8 times row 3. Technically, to make it a little more beautiful, we could, since negative 12 eighths, or negative 12.8, sorry, is 64 fifths. We could technically do this operation as negative 5/64 times row 3. I guess I don't know if that is prettier than that, but anyway. So again, just times row 3, so the only thing that's going to change is row 3. And then our last piece is now going to become 0, because 0 divided by that is 0. 0 for the last one, and then a positive 1. Alrighty. I'm seeing that the answer key has a negative 1.2 here, so I just want to double check that we, lost a negative. This is supposed to be negative 1.2, negative 1.2, negative 1.2, which kind of changes this. Because if we take row 2 and multiply by negative 9, negative 9 times negative 1.2 makes positive 13.5. Which makes this number 11.5. And this number, 11.5. And so then we're dividing by 1 over 11.5. And either way, we're still going to get 1. So We will ignore this piece up here then. All right, so that was obnoxious. We forgot a negative, and the only thing that changed was it to become negative. So that's annoying. Okay. All righty, good thing we have our answer key. All right. Then number 19. Sadly, wants you to do the same thing. And now it's a 3 by 4. So we need to find the row echelon form of the matrix, which again is used so that we can then identify, for instance, that z equals negative 9.2 in our answer. So looks like we'll have some decimals here. 1, negative 2, 3, 2, 6, and 12. 3, negative 6, positive 6. And hopefully we won't make any algebraic mistakes. Super. So remember that your goal is to get ones all diagonal here and zeros underneath. And there is kind of this idea or kind of path to do that. And again, the first path or the first goal is to get a 1 here and then zeros underneath. Then get a 1 here, zeros underneath, and then get a 1 here. Because if you do it in any other order, you end up messing up the other ones that you just made into what they were supposed to be. So first thing I'm going to do is try to make a 0 right here. So the opposite of negative 2 is 2, which means I need to multiply row 1 by 2 and add it to row 3. When doing this by hand, honestly, if I don't do this step in the middle here, I end up always getting my operations incorrect. So we will take the time to write it. So 2 times row 1 makes 2, 4, 6, and negative 8. We've already seen that I can do it with using this, so yikes. So then we have our row 3, which was still row 2. Because that's when we want to change. All right, so row 2 is negative 2 and 6, negative 6, and 2. Then we add them together and get our new row 2. And our new row 2 is 0, which is what we wanted, 10, 0, and negative 6. So 1, 2, 3, and negative 4. New row 0, 10, 0, negative 6. 3, 12, 6, 12. All right, then we take this new 1, 0, 3. And double checking that I didn't miss any negative signs somehow, because apparently I did that last time. Now we're going to try to make a 3 into a 0. So what do I add to 3 to make 0? Negative 3. So negative 3 times row 1, and then we're going to add that to the one we're trying to change, which is row 3. So the first 2 rows become the same. But our operation is negative 3 row 1, which is negative 3, negative 6, negative 9, positive 12. And that's going to be added to row 3, which is already 3, 12, 6, and 12. So adding those together, our new row 3 is 0, which is what we wanted. 6, negative 3, and 24. Yuck. All right, so 0, 6, negative 3, and 24. All right, so now we take our new matrix, and now we're trying to make this next row into a 1 so we can put zeros below it. So that means that I need to take 1/10 of row 2. So 1/10 of row 2, don't necessarily need to mark my operations here, keeps row 1 and row 3 the same. But then row 2 becomes 1/10, so 0 and 1, which is what we wanted, and 0 again, and then 6/10, so negative 0.6. Alrighty. Then the next piece is to get this 6 to be a 0. So rewriting. My cat seems to be hanging out with us here. So he's helping out with the calculator there. Good for him. All right. Thank you, Nesbitt. Okay. So to get a -6 in here, to get 0, we're going to need -6 times row 2, which is the only one that has a 1. And then we will add that to row 3. Right? Yep. Sounds good. Thanks, Nesbitt. All right. And so row 3 is the only one that's changing. And so we have -6 row 2. That's going to become 0. -6, 0, and something else. 0.6 times 6. 3.6. And it's negative, so positive, so 3.6. All right, let's check our negatives and our positives. Okay, and then row 3 was already 0, 6, -3, and 24. And so now our new row 3, after you add them together, is 0, 0, -3, and 27.6. Gross. Okay. Almost there. I'm going to get a piece of paper. Thank you, Kat. Okay. And so now our new matrix has 0, 0, whoops, -3, 27.6. And so to finally finish off number 19, we're going to take our new matrix and divide by a -3. So -1/3 times row 3 is going to reduce this to a 1. So all the diagonal will be 1. Everything underneath will be 0. So our new matrix is going to be 1, 0, 0, 2, 1, 0, 3, 0, 1, which is what we wanted, and -4, -0.6, and then our last digit here, which is 27.6 divided by -3, which is -9.2. And that is our answer. Sweet. Let's hope we never have to do that again. All right. I spoke too soon. So in number 21, which is the next problem, we now are finding the reduced row echelon form, which again means that the diagonals are 1s if they can be, and then everything else above it is 0s. So that's apparently not working in that one. All right. So to save ourselves some time in this one, since clearly if you got through those ones, we could pretty much figure out how to do row echelon. In number 21, I am just going to type it into the calculator. So let's go ahead and practice that. So in 21, our reduced row echelon form of the given matrix, which is 1, 3, 2, 0, 2, 1, 2, 4, 3, and 1, 7, 4. Okay, so that becomes, again, going to our matrix, going to edit, and this is a 3 by 4, which we already have. 1, 0, 2, 1. It's nice when they're just one number. Okay, so 1, 3, 2, double checking that we typed it in. All right, going back to our previous matrix operation here, going all the way down to reduced row echelon, which was this one. And then we're going to plug in for A, which is the matrix we just put in. And now we have our reduced row echelon. So we're going to have 1, 0, 0, 0, 1, 0. And then you'll notice that it's not going to be 0, 0, 1, because once you get 2 zeros down here, you actually end up eliminating the other variable. And so in that case, our reduced row echelon actually looks a little less than reduced. So there's a little issue there, but that is the furthest that the reduced row echelon can go. And if you don't believe me, you could do it by hand. Okay. So then number 23 gives you this matrix, which again is kind of odd to think of a diagonal being ones and zeros, because there really isn't a diagonal. But they do technically want this to be 0, and this to be 0, and this to be a 1, and this to be a 1 in order to be reduced row echelon. So again, on our calculator, we're going to plug in this for matrix A. So we're doing a 2 by 4. All right, double check that we have that based on the problem. 1, 2, -5, 3, -7, 1, -4. Okay, and since we're doing the same operation, we'll do second entry and get it back again. And now we have a reduced row echelon of 1, 0, 0, 1, which is what we were hoping for, but then also -1, 2, and 3, -1. All right. So moving on to number 25. In number 25, the directions are write the augmented matrix corresponding to the system. How nice is that? So all we want to do is write this in this format. So they give you 2x minus 3y plus z equals 1. So all the variables are on one side and they go x, y, z. So then we try that with the second one. Negative x would go first, plus y would go second, and negative 4z is going to equal -3. But then the last one, notice they only have 3x, no y's, and then minus z. So we are going to want to make sure that we put in this 0y here and also be aware of the coefficients of the ones that don't necessarily have a number. So our augmented matrix is going to be 2, -1, 3, -3, 1, 0, 1, -4, -1, and then 1, -3, 2. Again, kind of imagining that your dashed line is kind of separating those. All right, then number 27 wants you to do the same thing, but now it's for this system, which is 2x minus 5y plus z minus w. And that's going to equal -3. Technically, I do like to have it in alphabetical order, so I'm actually going to go out of order with the book here. So I'm going to rewrite this as negative w plus 2x, wx minus 5y, and then plus z. And then I'm going to write the next one in that order. So we'll have a w first, plus an x, no y's in that column or that row, and then 2 z's minus 2z. And then the last one has a negative w, 0 x's, 2 y's, and negative 3 z's equals 5. So again, this one's going to be a little bit different than the answer key in the book, just because I like to put my variables in order so that when I actually do the matrices solving with a calculator, I have them in order. So either way, negative 1, 1, negative 1 are the coefficients here. Then 2, 1, and 0, negative 5, 0, and 2, and I was going to write z, but 1, negative 2, and negative 3. Then our answers are going to be negative 3, 4, and 5. Alrighty. And now number 29. A lot of papers going on here. The directions say that we need to write the system of equations corresponding to the augmented matrix. And now instead of a variable set to a matrix, we're going from a matrix to a variable set. So they give you the matrix 3, negative 4, 2, 5, negative 1, and 2. And so remember that based on these types of matrices, this is your answers. And this is your x column and your y column, or whatever two variables you want. And so making that into our systems, I'm going to put 3x plus 2y equals negative 1, and negative 4x plus 5y. And this is my system. Super. All right, number 31 has the same idea, but they're giving you a 3 by 4. 2. Okay, and so in number 31, again, we are going to write it into this system. And the system is going to have these as our answers, and then our x column, y column, and z column. So we're going to get 2x plus no y's plus z equals 3. We also have negative x plus y equals 2. And then no x's plus 2 y's minus 3 z's equals negative 1. All right, then number 33. Going all the way to 37. Number 33 says, solve the system of equations by finding the row echelon form for the augmented matrix. So I'm going to be a cheater, and I'm going to just do it with the calculator. So let's see how that happens, because remember that the calculator does in fact make it into kind of some weird, I like how I'm writing this like it's a matrix. Anyway, the calculator makes it kind of into a weird set of digits, but it will still all work out algebraically. Okay, so again, we could get our reduced row echelon form by doing some matrix operations, but no thanks. So here's our matrix. the whole idea of a matrix in this case would be to make this easier rather than more difficult. So here's our augmented matrix, which I will put into the calculator, and then make the reduced row echelon, or sorry, just row echelon. Yeah. And so our row echelon form, going into the matrix, we have a 3 by 4. And so we'll put in 1, -2, 1, 8, 2, 1, -3, -9, -3, 1, and oops, I typed in something funny and it kicked me out. So -3, 1, -3, 5. And of course, since I typed things wrong, double checking. 1, -3, -3, 8, -9, 5. Okay. So we just want row echelon and not reduced row echelon. So going to the math column and down to row echelon format. We're going to do that for matrix A. And so we get 1, 0, 0, -1/3, 1, 0, and scrolling over 1, 0, 1, again diagonals of 1, that's what we wanted, and then -1.6 repeating, -5.8, and -0.8. Okay. So that means already, if this is row column X, column Y, and column Z or Z equals -0.8. Going up to the next column, we also know that Y equals -5.8. But then in the last column, we know that X minus 1/3 Y plus Z equals -1.6 repeating. But our X, we don't know yet. Our Y is -5.8. And our Z is -0.8. All right, so I'll solve this first here and get a value for -1/3 times this plus that. So we're going to get -1/3 times -5.8 plus -0.8. So we get X plus 1.13 repeating equals -1.6 repeating. So if we subtract 1.13, we get an X as well of, let's see, that's -2.69 repeating. Okay. Wait, 6 plus 1 is 7. So 7, 9 repeating. Okay. So our final answer is going to be -2.79 repeating, comma, our Y value, -5.8, comma, our Z value. Boop, 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 boop. Now, why in the world do they have a completely different set of numbers than we do? The answer is because. Well, if I don't like it, I'll come back to it. All right. Let's make the calculator do reduced row echelon before we move on. Oops. All right. All right, so reduce row echelon of A. Leaves us with negative 2 point, we got it, negative 5.8, and negative 0.8. But there's this. Okay, good job, good to know. All right, then still going through number 37. We need to solve the system by finding the reduced row echelon form. And so again, we are going to have the calculator do that. It'll be nice to see what the calculator spits out for number 37 because it says there's no solution. All right, so in number 35, we are given this set of systems, and I'm just going to right now rewrite it as its augmented matrix. And then we're going to make it into reduced row echelon. And so we're plugging it in. This assignment would have taken forever if we didn't use the calculator. So 1, 2, negative 1, 3, 3, 7, negative 3, 12, and negative 2, negative 4, 3, and negative 5. All right, let's see that I actually put them in. 1, 3, yep. 2, 7, negative 4. Negative signs. Okay. So we're doing the reduced row echelon of A. So we can retype that. And so our reduced row echelon is 1, 0, 0, 0, 1, 0, 0, 0, 1, negative 2, 3, 1, which means that x equals negative 2, y equals 3, and z equals 1. And so our answer is going to be negative 2, 3, 1, which is what the book got. So there you go. And then the last one, number 37. And again, if you did this by hand and you're wondering, wouldn't it be nice if Maggie did it by hand because then I'd see where my mistake was? You're just looking for an algebra mistake. So your guess would be as good as mine rather than me just working it out. So I probably wouldn't have done that anyway. Just double checking. Okay. And again, we're going to try reduced row echelon. So plugging in. Okay. And double checking. 3, 10, 4, 2, 5, 3. All right, so reduced row echelon of A. Oh, they say it works. Let's see. 1, 0, 0, 0, 1, 0, 2, 1, 0, 0, 0, 1. Oh, yeah, that's kind of weird because then the answer would have said that x plus 2z equals 0. See why I make z's with that little line? Because that would have been 22. All right, and then y plus z equals 0, and nothing equals 1. So it's this last piece here that doesn't necessarily allow this to happen, and so that is why this is no solution. That's funny. Nothing equals 1. Nope, it does not. Okay. So then we skip out of that and go to number 45. And in number 45, we are being asked to write the system of equations as a matrix equation of ax equals b, with a as the coefficient matrix of the system. So again, going back to that idea of how we would multiply by a inverse in order to solve. So the initial system is 2x plus 5y equals -3, and x minus 2y. So this is the way that would skip row echeloning, which is so not a verb. Okay, so that means that we're going to get 2 and 1 for our x column, 5 and -2 for our y column, and then that's going to be multiplied by our variables, which are x and y, and that's going to equal our answers, which are -3 and 1. So this is what they wanted you to get, whereas ax equals b. Okay. And now, of course, I want you to go backwards. So in number 47, they're giving you 3, 2, -1, 4, and that being multiplied by xy and equal to -1, 3. And now you're supposed to make it into a system. So our system is 3x's minus 1y, again, because this row would be multiplied by that column. And then this row, 2 times x plus 4 times y would equal -1 and 3. And so for number 47, the directions were write the matrix equation as a system of equations. All right. Then the next one, it says solve the system of equations by using an inverse matrix. So we want to use this idea in order to get the answer. So we'll convert them into this look, and then we will get your answer. All right. So those are the last 3. So in number 49, we are given 2x minus 3y equals -13, and 4x plus y equals -5, which again, in previous classes, you've been able to solve by graphing or elimination or substitution, but now we're going to use our matrices. Since I wrote that, it's going to be a tight squeeze here. Forgot to leave room for my variable matrix. Okay, so anyway, here's our A, here's our X, and here's our B. And so we're going to multiply both of them by A inverse, which will cancel that side, and leave you with A inverse times B. So in our calculator, we are going to put in our 2 by 2 matrix of 2, -3, 4, and 1 for A. And then for B, we're going to put in a 2 by 1 matrix of -13 and -5. So there we are. And so we're going to have the calculator do A, and remember inverse is right here next to the matrix, times B. And so our answer ends up being that xy equals -2, 3. Which, remember, when you're actually trying to get your answer, is a coordinate of -2, 3, where they would meet. All right, then in number 51, the matrix that's given is, or the system is 2x minus y plus z equals -6, x plus 2y minus 3z is going to equal 9, and 3x minus 2y plus z equals negative 3. You'll notice that a lot of times they don't screw it up by mixing these around, but hey, that could happen. So 2, 1, and 3 for our coefficients of x, negative 1, 2, and negative 2 for our coefficients of y, and 1, negative 3, 1 for coefficients of z is going to be multiplied by x, y, and z, and set equal to negative 6, 9, and negative 3. Alrighty. So again, if this is our A, and this is our X, and this is our B, we are going to do A inverse B and get our solution of a 3x1 matrix. So plugging in our 3x3 matrix of 2, negative 1, 1, 1, 2, negative 3, negative 1. Okay. I like when they're smaller, we don't have to scroll lower. 1, okay. And then your B matrix is a 3x1 of negative 6, 9, and negative 3. All right. And so we're doing the same operation as before. And so now we have negative 2 is our x, negative 5, and negative 7. So again, your solution is negative 2, comma, negative 5, comma, negative 7. All right, and then our last one, number 53. You're going to be an expert after this. All right. Ooh, has a lot of things going on. Negative y plus z plus w. I guess we'll just do it in the order that they gave us. And x plus 2y. I'm kind of writing them with spaces so that I can double check that they're all there. And the negative, 3x minus y minus z plus 2w. And then the last one, negative 2x, 3y. Turns out that in order to solve a system, you do in fact need 4 system rows, so 4 system equations if you have 4 variables. So notice 3 systems here because we have 3 variables, 2 because we had 2 variables. So just something to note. So our matrix is going to be 2, 1, 3, negative 2. Negative 1, 2, negative 1, 3. 1, negative 3, negative 1, 1. And 1, 1, 2, negative 3. That's going to be multiplied by our variable matrix, which in this case is x, y, z, w. And then that's going to equal our answer matrix of negative 3, 12, 3, negative 3. So we just need to type in our 4x4 matrix. And so all right. One, negative 3, negative 1, okay. Okay, and then our other matrix is a 4x1. And we're going to do negative 3, 12, 3, and negative 3. All right. And then our same operation, again, this was A, this is X, and this is B. So to solve A inverse B is X, and that is the variables of negative 1, 2, negative 2, 3. Again, normally I like this in alphabetical order, so I would probably just take the time to write x equals -1, y equals 2, z equals -2, and w equals 3. Just because writing it as a coordinate, the answer key actually puts it as this order, which is not really correct because w comes before x in the alphabet. All right. So that is your assignment. Sorry it was so long, but again, definitely going to know how to do each of these. Yay!